Hey everybody, it's Jen from Norman S. Wright. Last week I got a question about VAV box minimums, so I thought that'd be a good topic to cover this week. So let's get started. All VAV boxes can close off to 0 CFM. VAV box inlet airflow minimums are obviously dependent on the inlet size, where smaller inlets will have lower inlet CFM minimums. But can you put 1 CFM or 10 CFM through a 10-inch inlet? Technically you can, but you won't be able to measure it. So VAV boxes have minimum inlet CFMs. Since the VAV box is mostly sheet metal, the minimum CFM is based on what the VAV box controller can measure, not what the box itself can handle. So let's move this over and look at this. So let's draw a VAV box, and this is its inlet, a control enclosure with a controller inside, and this is the pressure transducer. Now you'll have a flow sensor in this inlet, and coming from that flow sensor will be 2 tubes connected to the pressure transducer on the controller. One side of the pressure transducer is connected to the total pressure side of the airflow sensor, and the other side is connected to the static pressure side. If you recall from one of the early videos, total pressure equals static pressure plus velocity pressure. So velocity pressure equals total pressure minus static pressure. So the difference between these two pressures is the velocity pressure of this VAV box at that airflow. The controller uses this to calculate the velocity of the air moving through the box, because velocity equals 4005 times the square root of velocity pressure. And this allows the controller to calculate CFM, because CFM equals velocity times area. Let's move this over again. Most pressure transducers can measure down to 0.01 inches of differential pressure. Different controllers may be able to measure higher or lower pressure differentials, but 0.01 inches should work for most everyday VAV box DDC controls. This differential pressure signal is measured by the flow sensor, so the flow sensor in the VAV box affects the VAV box minimum airflow. Flow sensors are designed to amplify the signal between the 2 ports of the flow sensor. So the differential pressure isn't exactly velocity pressure, it's an amplified pressure. And this brings us to the K factor. Every flow sensor has a K factor. The K factor is the CFM through an inlet that gives a differential pressure across the flow sensor equal to 1 inch. And you'll see it written as a number like 1487 or 673. Let's slide this over one more time. So the equation to calculate CFM from the flow sensor signal is CFM equals K factor times the square root of the differential pressure. And notice that inlet area isn't in the equation because that's part of the K factor number. So let's say these are 10-inch flow sensors, and the K factor for this VAV box with this particular sensor is 1487. So the CFM equals 1487 times the square root of 0.01 inches. That equals 148.7 CFM. So about 150 CFM would be the lowest that this 10-inch VAV box with this flow sensor in it could measure and control effectively. So let's bring all of this back on screen. That's how you determine the VAV box minimum inlet CFM. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.